Okay guys, so this is the review, and I want to go ahead and do the whole thing for you and put it up so that you can watch it if you need to, okay? It is your homework, even though I'm kind of doing it for you, but you have to watch the film. So let's do it. Number one, it says rewrite in standard form. So standard form, the first thing I'm going to do is rewrite, so the biggest exponent goes first. And I'm going to go kind of fast on this because you can always pause the video at any time you want, but I'll start with in standard form. Number one, I'll go p of x is equal to, that's my largest exponent, 4x cubed, then plus a 10x squared, plus a 3x minus 5. Okay, that's in standard form. The degree is obviously 3. The degree is the biggest exponent, so here is the degree. There's my degree is 3. And then the leading coefficient is the 4. My leading coefficient is the 4 because it's the number in front. And how many roots does it have? We know it's got 3 because of the degree 3, so it has 3 roots. Whether they're real roots or imaginary, it has 3 roots because it's degree 3, okay? Now, p of 2i is going to be to plug in 2i, so I'm going to go 4, and I'm going to go 2i cubed plus 10 times 2i squared plus 3 times 2i minus 5. If you simplify this, that's an 8 times 4 is 32. Let's see, I can just do my calculator. I have an I button on my calculator, which makes it so much easier. I'm going to go 4 times my 2i, and that is cubed, plus 10 times my 2i squared plus 6i, right? 6i minus 5. I'm going to get an answer of negative 45 minus 26i. Of course, that's I cubed, which is a negative I. That's an I squared, is a negative 1. And then you will get that if you simplify it the other way, okay? Easy. 3, divide. Now, first of all, since it's just an x minus 2, I'm going to use synthetic division on this. So I'm going to go ahead and take my negative 2. It's always the opposite, right? Oh, hold on, you can't see it. Take negative 2, which is the opposite of that, into upside down division. I'm going to go 3. There is no x squared term, 0x squared. I have to have the 0 in there. It's a placeholder. 4, negative 1. My remainder I'm going to put down here. If the remainder is 0, then yes, it's a factor. So here we go. Again, take down the first term, bring it down, 3. Multiply, get a negative 6. Add, multiply, I get a 12. Add, I get a 16. Multiply, I get a negative 32. So then I get a remainder of negative 33. So I already have the answer to this, and that is no. It's not a factor because I don't have a remainder of 0. The final answer is a 3x squared, 1 less degree, minus a 6x plus 16 with remainder plus the remainder of negative 33 over what we divided by, which was my x plus 2. Okay? Hopefully this is easy for everybody. There it is. Okay? Get all those, and those, and those. Okay? And that. Moving on. Number 3, let's graph this. So one of the things I can do is I can even graph this without a calculator. You can graph it with a calculator if you want to, but I do know I'm going to have for sure, I'm going to have zeros for number 3. I know I'm going to have a negative x squared, x minus 3, x plus 1. I'm going to have zeros for sure at 0, but twice. I've got a double root, and at 3 and at negative 1. Okay, and I know that's negative, so it's going to have end behavior of going to negative infinity at the end. Okay. Here's what I know. Let's take a look at this. I know a couple of important things, and I'll put it on the calculator, or you can if you want to. I don't really need to put it on the calculator. I can to check it, but 0 happens twice. That's a double. That's a double root. Because I get the 0 twice because of the x squared. That's why it's a double root, because I get x and x. 3 and negative 1. Okay. End behavior. I know it's got to finish coming down. So it's going to look like this. I know it's going to look like this. It's going to come up, Double root touches it, goes through it, back and back down. Now, if I'm unsure of myself, oh, what the heck, put it on Desmos or your calculator. I can just put it here. And then I can put in my negative x squared times my x minus 3 times my x plus 1. And I can graph it. Okay, there we go. Sure enough, what do you know? I'm so smart. It's exactly what it looks like, okay? Now, end behavior, so as x is approaching infinity, so as x approaches infinity, well, then y is approaching negative infinity, right? Y is approaching negative infinity. And over here, as x is approaching negative infinity, y is approaching negative infinity also. Okay, that's my end behavior. What's going on in the end? Okay, good. 4, find the roots of the following. Now I'm going to factor. Let me get a piece of paper out here that I can factor with. So find the roots by factoring. So number 4 will go x to the 4th minus 2x squared minus 8 equals 0. And you're going to need to factor. If you don't factor, you won't get full credit. X squared minus 4 plus 2, right? And then I'm going to have an x squared minus 4 equals 0 and an x squared plus 2 equals 0. If I add 4 and then I'll square root that, I'll get x is equal to plus or minus 2, right? Square root. And then on number this one, minus 2, x squared equals negative 2 square root. And when I square root this, I'm going to get an I answer, but plus or minus, because I need 2 answers. X equal to plus or minus the square root of 2i. Okay, there's my 4 answers, plus or minus 2, and plus or minus the square root of 2i. Okay, number 5. Again, I'm kind of going through this fast because you could always pause it, kind of doing your homework for you. On number 5, I have a 10x cubed, oops, sorry about that, 10x cubed, and I'll bring over a minus 6x squared plus 5x, and I'll bring over a minus 3 equals 0. Okay, 4 terms, so I'm going to factor it by grouping. So I'm going to group them. These first two have a 3x squared in common. Nope, I'm wrong. 2x squared in common. That leaves me a 5x minus 3. I like that because that's what I have here. Now I need them to match up, so I'm going to take out a 1. Seems odd, but I'll take out a 1, and I'll have a 5x minus 3. I did that on purpose so that I could have the same term twice. Okay, so then I'll factor that out. My 5x minus 3 it comes out, and what's left over is my 2x squared plus 1. Okay, now solving, set them equal to 0, 5x minus 3 equals 0, and 2x squared plus 1 equals 0. If I solve here, I'll get x, add 3, divide by 5, 3/5, right? I'll subtract 1, divide by 2, and then I'll square root, which tells me I'm going to get an I answer. That's okay. I don't mind I because I've got a square root of a negative number. I'll have x is equal to plus or minus the square root of 1/2 I, or better answer that I like if you ration, I'll take this, but a better answer that I like is plus or minus the square root of 2 over 2i. Okay, there we go. Now, moving on. So, number 6. When p of x is divided by x plus 2, the quotient is this. So what's happening is this. You know the answer, you know what you divided by, but you don't know the original. So you're going to do the opposite. You're going to undo it. So what I'm going to do is multiply. Okay, let me show you an example. If I have 5 divided into something, I get 4 with a remainder of 1. Hopefully you can say, well, Mr. Davies, that's got to be 21, right? And the way you did is went that times that, and then you added that. All we're going to do in number 6, same process. We're going to take on number 6. We are going to, take my 2x plus 1 times my x squared plus my 3x minus my 4, and then I'm going to add in my remainder of 5. Okay, so we multiply them. That times that, that times that, that times that, right? 2x cubed plus 6x squared minus 8x plus 1x squared plus 3x minus 4, and then plus my 5. Grand answer of 2x cubed plus 7x squared, sorry about that, minus 5x, and then plus 1. That's the original polynomial there. Okay, so you just have to multiply the quotient by the divisor and add in the remainder. Got it? Okay, moving on. So number 7, we have a cubic function that has roots of 4 and 2 plus the square root of 3. Well, hopefully, you know, if it's a cubic, it has 3 roots. So we also have an x equals a 2 minus the square root of 3i. You guys agree with that, of course, because they come in pairs. We talked about that yesterday. So then I'm going to, first of all, start off with p of x is equal to, well, x minus 4, because that gives me that root of 4. And now the other two, I'm going to use this x squared minus the sum of the roots plus the product of the roots, okay? All right, so let's figure out, first of all, the sum. We'll do that on the side. Sum of the roots, I'll have a 2 plus square root of 3i and add it to 2 minus the square root of 3i, right? 4. So I'm going to put a 4 right here, okay? Put the 4 there. And then the product, we're going to go 2 plus the square root of 3i times a 2 minus the square root of 3i, because I'm multiplying, because it says product, right? Product means multiply. I'm going to get a 4. I'm going to get a minus 2 square root of 3i. I'm going to get a positive 2 square root of 3i. And I get a negative square root of 9i squared. All right, let's see if we can simplify this a little bit. Right? These two cancel. This becomes a 3, and that's a negative 1. So I'm going to have a 4 minus 3 times a negative 1, because I squared is negative 1. That's like 4 plus 3, which is 7. Okay, so I'm going to put a 7 right here. Grand answer. Here we go. P of x is equal to, this is the polynomial. This is the cubic function, x minus 4 times x squared minus 4x plus 7. And if you use the quadratic formula and solve this, these will be the 2 roots that you get. Okay? All right, moving on. I'm going to get this done. And when I get it done, then you guys can work on it on your own, okay? All right, number 10. So a pen is divided into 3 different barns, okay? So we've got dogs, cats, birds, but we got to use fencing on all of these pieces, right? We don't have to put fencing on the barn. So the first thing I'm going to do is put fencing here, 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 and here. So those 4 pieces need to be made. So those pieces, we don't know how big they are. We're going to guess. So to start off with the number 10, my perimeter, which is 100, right, is now going to be perimeter for what's left over for this side is going to be 100 minus 1, 2, 3, 4, those 4 pieces of wire. So that is what we have for the length, 100 minus 4x, okay? Now, if we want to do area, well, that's no problem. I can do area, maximize the area. I can go area, I know, is width times length, of length times width, right? So it's just going to be x times 100 minus 4x. And so if I simplify this, I'm going to have a 100x minus a 4x squared. Now, you could graph it, and you can get the maximum. That works. I'm going to use negative b over 2a. It's faster for me because it is a quadratic. So I'll go negative 100 over 2 times negative 4, which is 100 over 8. What is that? Hold on. I should be able to do this at 12.5. I should be able to. So 12.5. So this tells me that each of these pieces should be 12.5, 12.5, 12.5, and 12.5. How much is left over? Well, I don't know. It's 100 minus 12, 4 times 12.5, right? So find the length. I'm going to go just simply 100 minus 4 times my 12.5. 100. Well, that's going to be 2550. So it's going to be 50. I can do that in my head. So the length is going to be 50. So it says, what are the dimensions? Well, that's easy. My dimensions are going to be, well, it's going to be my 12.5 by 50. And I can even find out what that area is just by multiplying it, right? So that's my dimensions, my width and length. And then my area, of course, is going to be, let's see, hold on, 12.5 times 50, and I get an answer of 625. And that's, I think, is that meters? Meters squared. That's in terms of meters, okay? There we go. Now, the domain. Well, let's think about this. The domain has to do with the x's, which is the width. So my domain can be, so let me write this down, the domain can be all the way from 0 up to, well, if I took all 4 pieces here, then it'd be up to 25, 25, 25, 25, 25, 25, and you wouldn't have any fencing left for anything else. So there's my domain. Okay. And then finally on the extra, we did a little bit of that problem in class. I will set you up on this one. I'll let you do it, but get a rectangular sheet of paper, right? And it can be any shape, and again, it depends on how you roll it. It has a perimeter of 200, so let's put x here, x here. So if I go my 200 minus my 2x, I'd have to divide that by 2 to put some here and some here. So I have 100 minus x and a 100 minus x. So if I roll it together like a jelly roll, right, look like that. X, and then the cylinder would have a height of 100 minus x. Now, volume of a cylinder is pi r squared h. So I'm going to use my 100 minus x for the height. Now the radius is a little bit trickier because that's the circumference. So I know circumference is equal to x, and the circumference formula is 2 pi r is equal to x. Okay? I need to know that because what I need to do is substitute in the radius in terms of x. So if I solve for r, divide by 2 pi, right, I'm going to get x divided by 2 pi, and I'm going to substitute that into there. And here is my volume formula, and then you just have to use your calculator to find out what is the maximum and the dimensions, okay? So that's how you do the extra, okay? All right, that's all I have. We'll work on this in class if you're here. If you're not in class, then you're just going to have to work on it on your own, okay? So we will take a test Friday and Monday.